Good morning, everyone. First of all, let me thank you all for joining this session. My name is Kirti Maluru. I'm the technical specialist at Autodesk looking after the manufacturing portfolio. So today's session, is a pretty interesting one. So, as you all know, in the last couple of years, we have seen a lot of interesting trends, that are coming up. It could be IoT, it could be virtual reality, it could be augmented reality, it could be your artificial intelligence, machine learning, generative design, etc., etc. Along with the additive manufacturing, etc., etc. So today what we are going to see is how we can leverage couple of these newer trends and how we can incorporate that into our day-to-day activity in terms of exploring and providing a very, very sustainable and an optimized design for your products. So before I start, a couple of housekeeping. As you all know, there is a contest that is running where you can have a chance to win Amazon Echo or certain Autodesk branded goodies. So, at the end of this session, there will be a poll which you have to take on the screen, followed by a survey or a feedback. Once this is done, there will be a lucky draw that will be published on 18th December at the specified website, that is auindia.in/webinars. So all the best, and I'm sure that you will enjoy this session. So let's go through the agenda for today's session. So basically, I'll be covering what generative design is all about, who should be interested, a bit detailed, in depth about the tool, followed by a couple of customer stories and how generative design is available to our customers or people who already have Fusion 360 with them, as well as certain summary and resources, followed by Q&A. And for all question and answers, I would suggest that you please post your questions in the chat panel, and at the end of the session I'll be more than happy to answer as many as possible. So before I begin, let's look at currently what's happening across the globe. The one thing that we are seeing that is happening across the globe is in terms of rise in the overall global population. And as per one survey, what we have seen is close to 4 lakh people around the world are moving towards a newer or a better economic status. That is basically 4 lakh people daily are getting into the middle class segment. So what is happening with that is there is a need for more. So all these people now have the buying power. With buying power, there is a need for more. Hence, more is inevitable. So there is a need for more of buildings, more of vehicles, more of transportation, more of apparels, more of consumables, etc., etc. But what we also know is there is a depletion in a lot of natural resources, raw materials, etc., etc. So what we know is less is a reality as well. Less of raw materials, less of natural resources, less of skilled labor, uh, that is there. But having said that, just because there is less of all these things, we still need to feed the inevitable need for more demand. So that is where, as a, uh corporate or as a company, we have an opportunity to be better, an opportunity for better design, for an opportunity for an optimized design, an opportunity for a sustainable design from a manufacturing standpoint. So today's discussion, we are not going to discuss about the micro or the macro economics of the more and less, but more from the manufacturing standpoint. But having said that, there is a need for a lot of new things to be done. But there are certain challenges that we see in the manufacturing segment. We basically have very, very limited time to ideate or do a lot of research in terms of having an optimized and a sustainable design. Where there is a dearth of skilled labor, and this is one of the most common challenges. Is there is very, very visible disconnect between the design and manufacturing. Both of them work in their own silos. Any late changes in the product design has cost imperatives, and striking the right balance between performance and cost is always a big, big, big task. And again, deep diving into more from a material productivity standpoint, every organization has a need or a wish list to lightweight their design to meet certain regulatory demands, or even to minimize their energy consumptions. They need to reduce waste, ensure that there are very, very less field failures, and everybody wants to innovate, but there is lack of time and skill, and not everybody is an expert on everything. So how do we ensure that to meet the need of the market, how technology can help in terms of providing sustainable design, but also ensuring that the overall time to market is very, very minimal as well? So before that, let's look at the traditional design process. In the traditional design process, if we are comparing as against time to market, we have couple of concepts which which undergoes an evaluations, uh, then it is tested for manufacturability and finally validated whether it can be produced or not. Once it is validated, then it moves into your production part of it. So this constitutes my overall time to market. So there is an iteration phase where there is limited concepts, and then there is design to production where evaluation, manufacturability, and validation is done, finally to be sent into production part of it. And this takes a considerable amount of time. So what if I told you that if there is a way where we can expedite this entire process and have a considerable productivity increase in our overall product life cycle? So enter Autodesk Generative Design, which is a design exploration technology, which is part of Fusion 360. And this is fueled with the intelligence of human, along with certain machine learning algorithms and artificial intelligence, and using the power of the cloud to very quickly throw us multiple outcomes which could be production ready. So generative design is a design exploration technology which can help us to come up with multiple design concepts for a single problem statement, which is pre-validated for form, function, and fabrications, uh, thus helping us to reduce the overall time to market. And if we look at the newer approach of the generative design process, we have in the iteration phase where multiple hundreds of different concepts which are pre-validated and checked whether it is manufacturable or not, whether it will function as per my tech requirements or not, as well as for multiple materials at the same time. And what you have is either a production ready or almost production ready CAD data which can be directly sent into the production environment. And this can have a significant reduction in my overall time to market, thus enabling a greater increase in my productivity. Now let's look at why customers are looking at generative design. So generative design, as I said, it is an amalgamation of human and machine interaction, which can help me to very quickly improve product performance by means of either lightweighting, or ensure it has got enough structural integrity and durability during the initial design phase itself. It can act as a tool which can help me to greatly increase my product innovations, explore more number of different design concepts, check for different manufacturing methods, and also ensure that there is no bias based on design that we as humans carry. And also it can help me to greatly reduce the product cost by lightweighting my components, or reducing the overall consumption of raw materials, or even consolidating different components into a single functional component as well, thus enabling our customers to have an improved customer satisfaction, an improved time to market, and be a market leader in your respective spaces. So what generative design will enable you is to have create multiple outcomes which are CAD ready outcomes, or almost CAD ready outcomes. And we will be also enabling in the near future a cost estimation tool where the engineers can evaluate the trade-off between the performance and cost to make the component as well. If I use this particular manufacturing method, what will be the overall cost that will be borne as against a different manufacturing method right within the tool itself, which can help me to very quickly make decisions and take into consideration the best manufacturing method that needs to be looked into. Now, we have seen in the last couple of years, there's a lot of discussions around additive manufacturing, and I know for sure that a lot of our customers have already adopted to one or the other form of additive manufacturing or 3D printing. And it's no secret that almost always additive manufacturing outcomes provides most of the time the best performance outcomes. So basically it can help me to lower my mass, come up with shapes which can be manufactured, come up with any kind of a crazy shape or an alien shape which can be manufactured as against different types of materials as well. But at this moment, there are certain uh, things which are prohibiting us to completely explore additive manufacturing. Is we see that the overall manufacturing cost is a bit higher in metal editing, and at this moment it is not ideal for large or high volume production needs for it. Now, the reason I am talking about why additive manufacturing is gaining traction in the industry, as well as it with lot of R&D and lot of money being pumped into its research and development, we will see that in the near future, additive manufacturing will become one of the premier manufacturing methods as well. Now, let's look at the overall manufacturing cost insight as against different manufacturing methods. We have already established that at this moment additive manufacturing is pretty costly and might not be sustainable for large scale volume production. But hands down, we know that milling, CNC milling is the most sorted manufacturing method when it comes to large scale volume production. And if it's a huge volume production, then we know that die casting by far beats everybody hands down when it comes to large production volume. Now, one of the reason I'm talking about this is there is a lot of confusion in the industry when we talk about generative design. Everybody assumes that whenever we say generative design, it is basically to adhere to additive manufacturing or 3D printing design. But what we have done uniquely is we have understood that uh, at this moment the industry might not be ready for additive manufacturing, but still we would also have to support our conventional way of manufacturing. That is, it could be your die casting, it could be your 3-axis milling, 5-axis milling, 2.5-axis milling, or even 2-axis cutting as well. So Autodesk Generative Design supports all these different types of manufacturing method, and we are including other different types of manufacturing methods as well that will come in the near future. It could be your different types of fabrication, it could be your different types of molding and tool design. So all those things will come in the near future as well. So at this moment, generative design supports additive manufacturing, die casting, different types of milling, as well as cutting operations as well. Now, let's look at why you should be interested, or who should be interested in testing out or trying out generative design for their internal purposes. So, as customers, I meet a lot of people, and any customer who have priorities in these areas. It could be your R&D investments, it could be in terms of additive manufacturing initiatives, it could be you have a huge lightweighting goals, cost reduction, or even new product introduction. Autodesk Generative Design could be the right tool for you to look into it and invest into it, to ensure that you are able to meet all your different types of priorities. Now let's take a look at couple of these example by means of a radar chart. From a scale of 0, which is not at all important, to a scale of 5, which is very important. If we look at the different types of customer profiles, we see that customer 3 has more number of initiatives which falls under my radar. So customer 3, customer 4, and customer 1 are most likely to gain benefit out of generative design, where it can help them to meet most of their internal business criteria or business priorities. And we have done this exercise with a lot of different customers. We do something called as a documented discovery with our customers, where we understand their priorities, their business challenges, and their business priorities, and we map as to how different technologies can help them in terms of achieving those priorities. And if I take a look at General Motors, where we work with General Motors very closely in terms of their initiatives on newer vehicles, on their electric vehicles, we found that most of their priorities fall fell under the different business priorities that they had carved out for themselves, and Autodesk Generative Design was able to fit right into their business priorities, and we were able to have a very, very healthy partnership with them in terms of enabling them to achieve their business priorities. And in terms of industry segments, basically this is industry agnostic. It could be people from any industry, they can start using generative design for their purposes, where if their entire focus is in terms of performance, lightweighting, innovation, and also looking at to different manufacturing initiatives, generative design would fall right into their priorities as well. So it could be automotive, aerospace, industrial machines, or even the consumer applications. So now let's look at generative design a bit deeper. So as I already established, generative design is a design exploration technology which is manufacturing aware. So basically, It is a design exploration tool which can help me to create tens or hundreds or thousands of different design concepts which are pre-validated for different types of manufacturing methods. It could be additive or any of the conventional manufacturing methods, and tested out for different types of materials, and the outcome will be a CAD ready or an almost CAD ready geometry which can then be sent into the production environment. Now, the way it does is, the way we work with the generative design is, it's basically a human machine interaction tool, where as humans we are very good at articulating a problem, defining a problem statement, or defining the goals of my particular problem. Now, with our intelligence to articulate the problem, with added with machine learning algorithms and artificial intelligence, which is pre-syndicated to follow or adhere to certain manufacturing principles in terms of form, function, and fabrication. And the best part is, all these machine learning algorithms or AI is not biased at all. It does not have any kind of design bias. And finally, equipped with the cloud computing power that is available, it can help me to create or provide hundreds or thousands of different design options for a single problem statement, out of which I can go ahead and start identifying the best possible designs which meets all my requirements or prerequisites. Now, I talked about design bias. So I'll give you a simple example for it. You can also think about it. If somebody asks me to design a chair, automatically my mind will go into a place where a chair will have either three legs or four legs. Reason being, from my childhood, I am used to seeing a chair which has either three legs or four legs. So most of the people, I'm not saying everybody, but most of the people will automatically start designing a chair which is having either three legs or four legs. But a system or a computer will not have this bias. This bias is called as design bias. We humans are sometimes tuned by certain design bias, but a system will not have this kind of a design bias. And if you look at this example, where the first one was actually designed by a human, where we see that overall the weight is around 10 kgs, and then we started applying you know intelligent concepts into it using generative design. The second model was much more lighter, and the third one, which was completely designed mainly for additive manufacturing, was able to reduce the weight by more than 70% of its initial or baseline design, at the same time ensuring that the factor of safety is not reduced at all, is not tampered with. So the factor of safety more or less remains same from my generative design to my baseline design. And the overall workflow is pretty simple and pretty easy. As an engineer, you need to set the goals and constraints. You need to define the loads, you need to define the materials, run it on the cloud. The entire solving happens on the cloud. You explore multiple results, and then if you want to, if one of the outcome is for additive manufacturing, then we have tools like netfab, which supports the entire design and manufacturing, especially for additive manufacturing, called as Autodesk netfab, which helps in terms of reducing the support materials, what should be the orientation, how it should be placed, and validate the overall 3D printed part. So basically the overall workflow is very, very simple and easy to use. Now let us take a look at couple of examples of how generative design can be used at various different products or product lines. So as I said earlier, generative design is not just limited only to aerospace or automotive. It can be used by industrial machinery or any of the different industry. So let's take a look at a pick and place assembly. So a pick and place assembly will basically have a modular structure which houses the vacuum pumps and the air channels. Now, if I want to reduce the overall weight of this particular modular structure, how will I go about it? So basically, if I have to define a pick and place assembly, will have a vacuum cup with air channels along with modular structures. So these structures, I need to make it much more efficient and lightweight. Uh, so I'll run the generative design on top of it, keeping in mind where it is being constrained, where it is being fitted, whether it is bolted, how it has to be placed, and what are all the different loads that will be applied during the operational activity, upon which I start getting different types of outcomes which can be then tested upon. So one of the outcomes is a shape like this, where it is much lighter than my original shape, where we can see a lot of materials have been removed. But at the same time, what you have to keep in mind is it does not compromise on the factor of safety part of it. Or it can come up with a very, very alien looking shape which can only be manufactured using a 3D printed part. But if you see, the benefit here is now three different components are fused into a single component. So now this is a part that is consolidated from three different components into a single working component. And then I can go ahead and test it out for various other manufacturing methods as well, not just 3D printed, but for others as well. So one of the example is 3D printed, where I am now taking this into netfab to check for my orientation, the support structures, and which is the best possible position that it has to be placed, so that I have more outcomes and less wastage. Or it can be tested for a milling operation, where I can go ahead and mill it and check for different types of cycle times that we can generate out of it. Or it could be even a casting option that you can go ahead and generate out of it. Or I can even run a 2.5x milling operations, where I can go ahead and further enhance the model to have various different shapes and sizes which meets the criteria for 2.5x milling operations as well. Now let us take a look at a different example. Now this is a bracket. So this was one of the first uh, you know benchmarks or proof of concept that we did with General Electric. So this is a GE bracket where they wanted to drastically reduce the weight of this particular bracket. So the entire problem definition or problem statement was defined, that the different loading conditions, the different materials, and they wanted it to test it out for additive manufacturing only. So in this case, as designers, what do I know? I know that this bracket is being placed and it is part of a much bigger assembly. It is being fixed at these four locations, and there is a clevis pin which will be connecting with another moving component across this particular region. So how will I start going about starting my work in generative design using Fusion 360? So there are certain things that needs to be defined. So I'll just repeat it again for the sake. In this case, what is my problem statement? My problem statement is this particular bracket is fixed at 4 location. There are 4 bolting holes here. Then there is a clevis pin that is going to be inserted across these cylinders. There are certain different types of loading conditions: upward load, axial loads, angular loads, or it could be even a torsional load as well that will be placed here. Next thing is I need to define which regions are important for me. So in this case, the regions which are important for me are these bolted holes and these locations for my clevis pin. So I define those 4 cylinders. I just model those 4 cylinders and I model these obstacles. So what it basically means is I need these holes. This will be my starting point for the model to be generated, and the area which is, or the bodies which are in red color, they are basically obstacles. It means that I don't want any kind of material to be added in those regions, because in these holes there will be a bolt that will be placed. So I don't want any material to be added during in this locations. So using this as a starting point, how do I start defining my conditions? So this is Fusion 360. So I have Fusion 360 here. So as if people are not aware about what Fusion 360 is all about, Fusion 360 is a cloud-based 3D CAD CAM CAE tool which can help you in terms of your entire product life cycle in a single tool itself. So if you look at here, I can do my entire design, generative design, my rendering, animation, simulation, nesting, CAM, as well as create my documentation or drafting right within a single window itself. So what I need to define is basically these are my regions which has to be preserved. What it means is this is required for me to start iterating to create multiple concepts. So these 4 bolting locations and the locations where the clevis pin is going to go. And next is I also need to define my obstacle geometry. It means that, there will be a pin that will be inserted here. So I don't want any kind of material to be added here, because, if you see here, so there will be another component that will be placed which will be assembled by means of the pin. So I need to also ensure that there is no material that is added here. uh, there should not be any material that should pass through my bolted holes as well. So I just define my preserve geometry and my obstacle geometry. Next thing what I need to define is my constraints. So how it is being constrained? I know that it is being constrained at these 4 locations, so it is fully fixed. And then I define my forces. What are all the different forces that will be acted here? So in this case, it's a torsional force that will be acted, one in this direction and other in this direction. So I go ahead and define it. I can add different types of forces, pressure, moment, and bearing load, and define my forces here. So once this is done, the next thing I need to define is what are the objectives for it. Do I want to minimize mass, or do I want to maximize stiffness? So if I want to maximize stiffness, I need to provide the safety factor and what is the bare minimum mass target that I would want to achieve. If you also want to test it out for your modal frequencies or vibrations, I can go ahead and define that as well. So I can define my first mode frequency that is there, uh, and what should be the maximum displacement that it can incur during the creation of different models. So I can define my displacements in various different directions as well. And then I define my different manufacturing methods. So I define how many pieces I want, the different types of manufacturing methods, whether it is, if it is additive, what should be the orang angle or the minimum thickness. If I am defining it for milling, whether it is 3-axis milling, 2.5-axis milling, or 5-axis milling, what should be the tool direction, only in Z plus or Z minus, or in all directions. You can define your tool diameter, shoulder length, head diameter, everything. In this case, I'll not be using milling. You can also perform 2-axis cutting operations as well in different directions, X, Y, or Z. And if die casting is something that you want to look into, I can go ahead and start defining from where should be the ejection direction be, the draft angle, and the minimum and the maximum thickness can also be defined. So once I define my manufacturing methods, I can go ahead and start adding the different materials on which I want to go ahead and add. I can analyze or iterate up to 10 different materials for a single problem statement. So it could be different types of materials that is available. It comes with a huge library of different materials, either for metals, liquid, glass, and other things. You already have a huge library of different materials that is available, and then you can go ahead and generate. And what it will do is, once you define generate, it will push the entire data onto the cloud, and you can very quickly different concepts will be created and sent to your system for a detailed study or analysis on top of it. So in this case, I have already ran the iterations, and I have multiple different types of designs or concepts that has been created for different manufacturing methods, whether it is additive or it is unrestricted, or if I would have defined other manufacturing methods that would also be available for different types of materials, whether it is stainless steel, different grades of stainless steel, uh, uh, or it could be titanium or any other materials that you have defined, or based on the different mass. So it varies from 1.64 to 4.63. Or even on the right hand side, you can go ahead and start filtering out by volume, by mass, or your von Mises stress, factor of safety, etc., etc. There are different ways by which you can go ahead and filter out solutions. We have thumbnail views. I can actually go ahead and do a side by side comparison of different types of results that has incurred, or a scatter plot view where you can see what is the outcome for this particular as against minimum factor of safety and materials, or it could be a manufacturing method. Or if you want to check it for a minimum factor of safety, I can go ahead and start analyzing it for different types of results or outcomes that is available. So let's look at couple of those things. I can go ahead and have a much more detailed understanding of my particular design. So it shows me how my design has been created. I can check for if there are any kind of stresses that are generated. I see that there are some stresses that are generated here. What is the maximum one measures stresses? What is the mass and other things? Or I can even go ahead and compare it with different, have a side by side comparison between different models as well, as against two different models. I think both of them are more or less same, but I hope you got the gist of it, where I can go ahead and see how the overall factor of safety is, and the strength, where my stresses are, high stresses are, and all those things can be very easily be viewed using the outcome generator in generative design. So I hope you got a point. The overall workflow is very simple. You need to define the goals, you need to create preserve regions and the regions which will act as an obstacle, define your loading conditions, define constraints, um, add materials, add different types of manufacturing methods, and you run the analysis, and the analysis runs on the cloud, and very quickly it will throw you different types of results through which you can go ahead and start filtering out those results which best suits your requirements and needs. Similarly, we have another example. This is an example of a two-wheeler, of a swing arm of a two-wheeler, where the customer wanted to drastically reduce the weight of it. So they basically first identified their design goal, where it is being constraints. They mapped it for various different manufacturing methods, materials, and their objectives, out of which they generated multiple outcomes, and they started filtering out those which follows their particular technical criteria. And using those 3 or 4 final design outcomes, they did a much more deep dive on the outcome in terms of analyzing it for various different types of FE analysis to understand its structural integrity, whether there could be any failure that we can anticipate. And then using the CAM functionalities, which is right within Fusion, they were able to create the CAM programming for a hybrid manufacturing, that is basically your 3D printing and finally finishing it off with a conventional manufacturing or subtractive manufacturing. So they used NetFab to basically understand how the support structure should be and the structural integrity of the support structure, and finally used Fusion CAM to do the finish touches on that particular swing arm. Now this is being manufactured and this is already being rolled out to their customers, for with which is a much more efficient as well as a reduced weight of the original swing arm. Now let's look at couple of customer stories around the world, across various industries and across various different types of manufacturing methods. The first one is General Motors. So we work very closely with General Motors in terms of their business goals for to have a lightweight vehicle as well as in their electric vehicle program, where one of their concern was not only in terms of reduction of weight but also in terms of reducing the number of moving components. So one of the major goals for them was to have more number of components fused into a single component. So they basically identified one of the seat belt bracket, and they wanted to fuse or consolidate 8 moving components into a single part, which should be 40% lighter and 20% stronger. So they used Autodesk Generative Design, and they were able to come up with multiple outcomes, and they did a deep dive in terms of different manufacturing methods, in terms of its structural integrity and validation, and they were able to freeze upon couple of those designs, which is now being tested rigorously in terms of its feasibility and workability part of it. Uh, this is a completely 3D printed part, and it is being researched and tested in their facility right now as we speak. So as I said, this was basically a seat belt bracket that they used, and they were able to successfully fuse 8 moving components into one single component. Similarly, this was for an aerospace customer, where they wanted to, and as you know, in either in automotive or aerospace, every gram that is saved, or reduced, has a big this thing on their performance and their fuel consumption. So they wanted to drastically reduce the overall weight of their brackets that is being used at multiple locations, and they were okay with additive manufacturing and using generative design. They were actually able to reduce their overall weight from 325 to 135 gram, and at the same time using titanium as their material. Again, one more manufacturing customer, Claudius Peters. So they basically make these clinkers, which is being used in a cement production facility, where this particular clinker is subjected to very high temperatures. And currently, this is a very heavy component. They use generative design to drastically reduce the weight of those clinkers from close to 150 kgs to around 50 kgs. So they were able to reduce two-thirds of the overall weight of those clinkers, at the same time not changing their manufacturing method and using the conventional manufacturing method to manufacturing these particular component. And this is being used at various stages. This is not just a one-off component. So there will be hundreds and thousands of these particular components that will be used. So imagine the amount of cost and material that is being saved, as well as they are also being a sustainable customer in terms of reducing the overall consumption of raw material for the manufacturing of these particular component. Again, we work with lot of different space organizations. So NASA is one such, where for one of their landers, they wanted to use generative design and come up with an entirely different shape, which led them to 35% reduction in the overall mass. So imagine 35% reduction of their overall lander. Imagine the amount of fuel that will be saved during the launch process. And they are validating it with various different types of manufacturing methods, where it will be a hybrid of different manufacturing methods that will be used for the final production of it. And finally, Airbus is using generative design to drastically reduce the weight of one of their partition walls. So you would have seen a partition wall in an aircraft that basically separates the cabin with the crew. So currently, it's a hard mass of metal or a composite that is being used, which is very heavy in nature. And they wanted to drastically reduce, because again, reduction in weight is uh, reduction in their fuel consumption. So they basically wanted to reduce the overall weight of those partition walls, and they were able to reduce 45% of the mass from their original design, and they were able to come up with an entirely new shape which follows all their structural and functional protocols as well. So the way our customers around the globe are using generative design is either to have an entirely new design exploration or a design concept for their baseline design, or to even look at impossible geometries, or even enhancing their existing models or design for much more innovation, for much more performance and lightweighting. Or some customers are utilizing generative design to consolidate their multiple components and have a single fused component out of those different sub-assemblies as well. Now, what we are also seeing is there is a lot of confusion in the market in terms of what generative design is and what topology optimization is. Now, to simplify it, in topology optimization, you basically have a shape. You already have a shape, and you are reducing the material or weight of that particular shape by removing certain portions of your material. But in generative design, you are starting from a clean slate or a clean board where you just have the design goals or the design intent out of which a shape will be generated for you, which follows all manufacturing protocols in terms of form, function, and different fabrication methodologies. Now, there are various ways by which generative design is available to our customers. As I said earlier, generative design is part of our Fusion 360 offering, where Fusion 360 is a cloud-based CAD, CAM, and a CAE tool, where now generative design is a part of Fusion 360. So if you are already a customer who has Fusion 360, you will get generative design as part of Fusion 360. And along with Fusion 360, you will get 100 cloud credits. I will talk about what cloud credits are in the next slides. Now, if you're a customer of Autodesk Product Design and Manufacturing Collection, which comes with 13 plus different product portfolios, right from Inventor, Nastran, CAM, Factory, 3ds Max, Navisworks, it also comes with Fusion 360. So Product Design and Manufacturing Collection, customers who have product design and manufacturing collections also have Fusion 360, and generative design comes along with Fusion 360 for customers who already have product design and manufacturing collection. And for those who are looking at procuring generative design, you can either look at Fusion 360 as a standalone tool, or you can procure product design and manufacturing collections in which Fusion 360 is a part of. Now, as I said earlier, Fusion 360 and generative design works on the cloud platform, and the entire analysis or iterations to generate multiple outcomes happens on the cloud. So when it happens on the cloud, you need certain cloud credits to consume and run those analysis. So for you to run a generative design study for your setup and to generate outcomes, you will need 25 cloud credits. Imagine cloud credits as a unit. So you need 25 units of cloud credits to set up and generate the outcomes. And if you want to explore the results, where you want to now take the data that comes either as a step file or directly in Fusion, where you want to download the outcome as a step file or any other file format, and then you want to maybe further refine your model in your existing CAD environment, you need 100 cloud credits to download the outcome. So on an average, roughly, it is not a number set in stone. On an average, to run and explore results, you would need 125 cloud credits. And there are various subscription models that we have that can enable you to use the cloud credits. We have Fusion 360 with cloud credits, which comes with a pack of 1500 cloud credits, or 5 subscription pack of Fusion 360 that comes with 7500 cloud credits. I would request, if you are interested, to reach out to your partners, to your or your resellers, or even to us directly to check for the pricing and other part of it, and we'll be more than happy to help you on that front. Now, having said that, there is a good news. There is a great news actually. Now, for our customers, what we have done is, if you want to try and test out generative design, we are giving free generative design till end of December 31st, 2019. So you have unlimited access to generative design cloud credits till December 31st, 2019. So if you are a customer and if you have access to Fusion 360, you can test out and you can execute multiple benchmarks, projects, and proof of concepts using generative design and the cloud credits, which is completely free till December 31st, 2019. You have close to 30-35 days through which you can go ahead and test out generative design. So I would request everybody to have a look at generative design, identify programs or identify projects in your organization or in your design process which you can, where you can leverage generative design and test out various different outcomes. And because now it is available free of cost till December 31st, 2019, you can go ahead and avail this uh, unlimited options till December 31st. Uh, and for people who already have Fusion 360 with them, there are a lot of summaries and resources that are available within our portfolio. You can go to our website and see a lot of data, intro videos, help videos, getting started documents on generative design. There are a lot of customer case studies, irrespective of different manufacturing methods, different industries, which you can go through and see how they are leveraging generative design to be much more efficient, optimized, and be a sustainable company. Again, as I said, if you have already installed Fusion 360, you have a lot of self-help tutorials that are available right within Fusion 360, which can help you in terms of step-by-step procedure in terms of using generative design right from scratch, how to set up the model, build the model, run the model, and analyze the model and generate useful outcomes out of it. With this, I end my session. I hope it was useful for you. And again, I encourage each and everyone to start utilizing generative design and the program that we have of having unlimited cloud credits till for generative design till December 31st, 2019. Please go ahead and utilize that program. And if you have any questions or if you want to know more about, either you can ask your questions in the chat panel, or where to reach us, either reach us or our partners, and we'll be more than happy to help you out. Now, before I go into Q&A, there will be a short poll. So I request each and everybody to participate in the poll, uh, where you will be asked a couple of questions, and I'll give you sufficient time to answer those poll. So request you to please respond to the poll question. People are still voting, so I'll give them another 5-10 seconds. And the last question. Yeah, thank you very much for participating in the poll. So if you have any questions, please feel free to ask in the chat panel. I'll be more than happy to take your answers. Take your questions, sorry. There is a question it asks, is this a plugin for so, do we need a basic drawing for doing further design? So basically what you need is a design goal. What is the design for, where it is being fitted, and the different working conditions, and you should be able to use generative design. Yes, we are recording these sessions and it will be available for you. Is there a plugin for Revit? I'm not sure I understand this question, but I can bring data from Revit into Fusion 360. There are various formats from which I can bring my Revit data into this thing. Can we directly put inventor model to Fusion for generative design? Absolutely, you can put that. Now with any CAD in Fusion 360, I can bring in inventor model into Fusion and then use generative design and take back the resultant outcome back into my inventor as well, either for directly sending it for creating documentation or for further refining my design as well. Uh, to sync between mass production and prototype will Fusion 360? Yes. So what I said earlier, we are now releasing a new costing tool that will be part of generative design, which will help you to basically gauge the performance versus cost part of it. Do you have a plan to describe about pharma intermediates manufacturing? We are interested. I don't think I fully understand the question, but we can connect with you offline and see if how we can take the discussion forward. Yes, till December 31st, tokens are available, cloud credits are available. You can go ahead and use it. Uh, for us to utilize generative design, we need cloud credits. So cloud credits is required for us to execute the design outcomes. Fusion model is possible to convert in Revit as an intelligent model. I don't think at this moment it is possible. It will be by means of a neutral file format, but yeah, at this moment it is not possible. What is the possibility of rendering capabilities in Fusion 360? So Fusion 360 comes with its rendering tool, either in-house rendering or you can use cloud rendering, where you can create very, very high rendered photorealistic imagery or videos as well. Can we generate fabrication detailed drawings? Yes, Fusion 360 comes with documentation as well, so I can create drawings of my model as well. Does Fusion crashes while loading models from generative design? No, it doesn't happen because it's just an act of loading models. You might want to check your system, but usually it doesn't crash because it's loading model and then taking into generative design. Um, I'll just take a last question if there are any questions. Else, we can end this session. Yeah, okay. Yeah, I think we have overshot the time. I see that questions are coming in. We will answer them one by one. Uh, with this, I end my session. Thank you very much, everyone, for attending this session. I hope it was useful, and please reach out to us or any of our partners if you want more information about Fusion 360 and generative design. Thank you. Thank you very much.